Hi folks, we're going to take a look at page 270, number 30E. So they're asking us to find the derivative of this function here. So we're going to have to use the chain rule twice here, but in slightly different ways. So I'm going to start by just rewriting this so that we can really see where we're using the chain rule. So here, just remind you here that when we write tan of x squared, it's tan of the whole input x squared. And normally I wouldn't bother writing this, but just to be very clear that tan squared x means tan of x all squared. Okay, so now we'll go ahead. So this is obviously just a subtraction, so I can use the subtraction rule. So first I find the derivative of this thing here. Okay, so what we call our u, okay, is going to be our x squared. So the first thing we have to do is take the derivative of tan u with respect to u, and that'll be secant squared u, which of course u is just x squared. So secant squared of x squared. And now we have to take the derivative of this u with respect to x, so that's just 2x. Okay, now we'll take the second derivative. So in this case here, our intermediate variable is tan x, so we'll call that v here. So first we're taking the derivative of v squared, which is 2v, so 2 times tan x, and now we have to multiply that by the derivative of v with respect to x, which is just secant squared x. Okay, and there you have it. Now we just clean everything up. So 2x secant squared of x squared minus 2 tan x secant squared x, and there's no particularly nice way to simplify this here. Okay, now notice that here we have secant squared of x squared, secant squared of x. There's no way to factor anything out. These are two different expressions. Okay, so again, just to recap, if you find yourself a little confused as to how to apply the chain rule on a particular function, try to rewrite it in a more familiar way. Okay, like we did here. Even if it means an extra step, might be worth your time. Okay, that's it for this one.